Morning, guys. So today we're going to be looking at the homework solutions for yesterday's homework, 323. So the first one, the Genetics and IVF Institute conducted a clinical trial of the Y-sort method and designed to increase probability of conceiving a boy. As this book was written, 51 babies were born to parents using the Y-sort method, 39 were boys. Use the sample data to construct a 99% confidence interval estimate of the percentage of boys born to parents using the Y-sort method. Based on the results, does the Y-sort method appear to be effective? Why or why not? To do that, we're going to look at our formulas. First, we're going to have to find the margin of error, and then we're going to have to add, subtract it to our p-hat. So first, let's write down what p-hat is and all of our other variables. So n, we have 51 babies. And then p-hat would be 39 out of those 51. One minus that would be q-hat. So q-hat is 12 out of 51. Remember, they're complements of each other. So 1 minus 39 over 51 is 12 over 51. And then our alpha value, since we're looking at a 99% confidence interval, that makes alpha 0.01. So you could remember those values, you could look them on the chart, you could do the inverse norm, whichever one you want to do. I'll look them up on the chart and then use the calculator so you can see both of those ways. Alright, so if we look up, and what are we going to look up? We're not going to look up alpha, we're going to look up alpha over 2. So not 0.01, but 0.005. And I'm going to just be lazy looking at negatives. That way I can look up, 0.005, oh no, too many O's. Here we go, we're getting there. Oh, hey look, there's an asterisk. Oh, for 0.005, it's right here, negative 2.575. So that means our Z of alpha over 2 is 2.575. So remember, for these, Z is both positive and negative. So if we're just looking at Z of alpha over 2, we're talking about the absolute value of it. Because we're going to use the negative one here and the positive one here. So it's easier just to calculate the error using the positive version and add and subtract it respectively. And if we wanted to, we could look up 0.995, and that would give us the positive 2.575. Now we could also use our calculators, which I have to reopen, sorry. Sorry about that. All those are popping up. Move on to the next one, or the next part of calculating the error. So E is equal to Z of alpha over 2 times the square root of T times Q over N. There they are. So to get the Z score of alpha over 2 on the TI, we're going to look at the inverse norm Then you could do 0.005. And again, just take the positive of that. 2.576 if you use a calculator. See the chart. It says 2.575. The calculator will give you 2.576. Slightly different, but it's fine. On the Casio, we're going to go to our inverse normal. Oops. And type in 0.005. Leave those alone. 2.57, again, 6. So if you're using the calculator, you get just a slightly different answer. We can go with the 2.575 though. So now E is equal to 2.575 times the square root of P hat times Q hat divided by N. And extend that root a little bit. All of that's underneath the radical. Let me grab the TI because it's more complicated to put it in that one. Of course, you actually don't have to put it in this one. But if you're using another calculator that doesn't have math type like this one does, the process is the same. In fact, let me make it look like you'll see it. Okay, so you type in 2.575 times the square root. Always open up a parenthesis for your numerator. I've got another fraction, so open up your parenthesis for a numerator. 39 over 51. Close the parenthesis for the first fraction. Times, you could just use parentheses there, it doesn't matter. 12 over 51. Again, including our fraction in parentheses. Close the fraction of the numerator. So this is the entire numerator from here to here. Divided by, we really don't need parentheses, it's just one thing, I'm going to put it anyway, 51. That's the denominators open and close, infinity close the square root. And now, we get equals 0.1529. Okay, I'm going to use the Casio, so I'm actually going to do the 2.576. Let's see what the difference is. And remember, our final answer is only around 36, so it probably won't make a difference at the end. So mode 1, 576. That's what the calculator gave us, so that's what I'm going to type in here. Times the square root, fraction, 39 over 51 times fraction 12 over 51 over 51. So 0.1530 as opposed to 29. So really, if we look at it, not a big difference there. It probably won't make any difference whenever we're calculating our confidence interval. Now we've got our error. We need to find the confidence interval. So we're going to take p hat and subtract that error. And again, we're going to go 3 sig figs. So let's see. I'll grab this one. P hat was 39 over 51. And subtract my answer. So I get 0.6117, but again, this doesn't matter. It's just going to be 0.611. or 612, sorry. So if I use the TI, well, I do 39 over 51 minus that answer. Let's see what it's saying. 0.612. So again, using the chart or the calculator didn't give you a difference there at the end. So our confidence interval would be 0.612, and then I'm going to add that, 39 over 51 plus, and I'll just type it in, I get 0.918. And if you do have a different answer, it will be at most one-digit difference here in the output place. So it really won't be that big of a difference. TI users, though, remember, if you just need the confidence interval, you can just type it in. Go to Stat, Test. Not sure exactly where it is. For me, it's A. It might be different for you, but look for that one prop Z interval, one proportion Z interval. That's what we're looking for. X is 39, N is 51, confidence is 99. And there it goes, 0.612 to 0.918. That's our confidence interval. And it does give you T hat right there. If we divide 39 by 51, it'll be that decimal right there. Okay, number 2. Same thing here. We're going to construct a confidence interval. So let's see. We got that many people, and that many of them had brain cancer. So this is a Danish study to see if cell phones cause brain cancer. Originally we had that percentage for brain cancer if they didn't use cell phones. Use the sample data to construct a 95% confidence interval to estimate percentage of cell phone users. So we're not messing with this number. We don't need it. For part B, though, we'll probably use it to compare our results. So we're going to estimate the percentage of cell phone users who develop brain cancer. Let's do that. So again, in 420,000, 95, T hat, 135 out of that N value. And if you're a TI user, you're done. Just type it in. So I'll show you that. Clear it. So we go to Stat, Tests. Quickly go the other way. One prop Z interval. This time X is 135. And N is 420,095. And we want that 95% confidence interval this time. Okay, I'm going to write this down exactly as I see it here, so we can talk about sig figs. In fact, I'm going to screenshot it. So here's our confidence interval. So I'm going to rewrite these numbers in standard form. Make sure you do. That's going to be 0.0002 that's all the calculator gives you, that's what you're going to put. How many sig figs do these have? They only have 2. So if that's all the calculator gives you there, that's all you're going to put. You can't do much more than that. I mean, I guess you could stick a 0 on the end of there, but they don't, so don't even worry about it. Alright, so this should be our answer. Let's see what we get whenever we do it by hand. I'll just stick that down here out of the way. I'll look at the result of it later in a minute. So Casio and hand users. We're going to do 420, double, 2 O's right there, 95, minus 135, that's 419960. Now, why did I do that? Well, I could figure out what Q hat was. Remember, P hat and Q hat are complements. So there's P hat, there's Q hat. We also need alpha. Alpha is 0.05, looking at our 95% confidence interval. So you can use the chart. Again, we're not going to look at 0.05, we're going to look at 0.025 half a time. Again, I'm lazy, I just look at the negatives, 0.025. Right here somewhere. Right. There it is. 1.96. Again, just drop off the negative. So z of alpha over 2 1.96. We will be using those particular z-scores a lot, so if you just remember them, you don't have to worry about looking it up. And if you have a calculator, you can just do inverse norm, save yourself some time. .96. Okay. So our error in the formula, our error is z of alpha over 2 times the square root, p hat times q hat and we divide that by n in a minute. Sorry. Divided by n. And that'll give us our error. So grab yourself a calculator. I'm going to use a Casio to save some time, and since if you have a TI, just type it in and get the answer immediately. Mode 1, 1.96 times the square root of a triple fraction. Times and put that over our n. Oops. And that should be our error. Now it's really important you keep all these decimals. That's got 4 zeros behind it. But you know what I'm going to do? To save it, I'm going to store it. So the Casio and the TI can both store things. Here's the stow button right here above the recall button. And I'm going to call it A. Let's see if this works. No, it didn't. No. Dang it. Oh. I don't know. Sorry. Very sorry. Yeah. 1.96 times square root 135 over 42095 times 41990 over 42095 divided by 42095. And this one I know how to store in. I'm going to take that and hit the store button. You can choose any letter. I like to use the X button because I don't have to hit alpha first. And now that's X. So I'm just going to take my N, my P hat, and I'm going to add X to it. And I'm going to do the same thing, but I'm going to subtract X from it. Oops. So if we do it by hand, we can get more decimals on it. So that would be 2.67 instead of just 7. But again, either way you do it, it's fine. I'll take that. We've got so many decimal places that the TI doesn't give you 3 sig-figs. I'll accept it. So our margin of error here would be let's see, it's E-4, so I'm going to go back with 3 zeros, then 267. And if you want to leave it in scientific notation, that's fine as well. Just make sure you have your 3 sig-figs. 3.76. And let's compare that to what the TI gave us. Yeah, same thing. Just one less sig-fig. Okay. So that's part A. Sorry about the whole store thing on this Casio. Do cell phone users appear to have a cancer of the brain nervous system that is different from the rate among those not using cell phones? Why or why not? Well, earlier they found this result, 0.0340%. Oh, look, we got so many more zeros. Oh, wait, that's percent. So if we write that as a decimal to compare it, use a nice purple color for B. Okay, 0.000340. If we compare that, that's right there in the same range. I mean, it's not outside of the range at all. It's like, it's right there in the middle. So, no cell phone usage, what is that? Cell phone users do not appear to have a different rate of cancer, something like that, since the proportion of non-cell phone users lies in the 95% confidence interval of non-cell phone users. Something to that effect. Basically, no, that number is up in that confidence interval. Move on. Okay. Now, another interesting test they could do is whether cell phones cause sterilization, since we usually keep it right there in our pockets. Could be next study. Music industry must adjust the growing practice of consumers downloading songs instead of buying CDs. Yes, book is kind of old. It therefore becomes important to estimate the proportion of songs that are currently downloaded. How many random such song purchases must be surveyed to determine the percentage that were obtained by downloading, assuming 1 to 95% confidence that the sample percentage is within 1% of the true population. Okay, so what are we looking for here? We're looking for N. What do we know? Well, alpha we need to be 0.05. Error, 1 percentage point, 0.01. Is that all we got? That's all we got. So I'm going to go with my formula. Here it is. It didn't give us p hat or q hat. I'm going to use this one. Assume they're both 0.5. This is the formula we're going to use. We got alpha to calculate this. We've got our error. We don't have any information about the proportion. Since we don't have any information, we use this one. We can both p hat and q hat at 0.5, multiply them together, we get 0.25. So let me get my z-score, which we literally just did, it's 1.96. See, right there, alpha 0.5. The z of alpha 2 is 1.96. I'm not going to go through that again. So z of alpha over 2 is 1.96. Now we need to plug it into this formula. So we take n equal 1.96 squared times 0.25 over 0.01. And don't forget to square it. Happens to me sometimes. So really doesn't matter what calculator you're using, you're just going to type it in. It'll be most difficult on a non-math type calculator, so I'll do it over here using not math type. So first we have a numerator. Put it in parentheses. Square that thing. .01 and square it. Oops. So numerator in parentheses, denominator in parentheses makes you square things appropriately. 9,604. All right. So if we we're done. If we get 9,604 songs and look and see how they were downloaded, that'll tell us what proportion are being downloaded versus bought on CD, or 8-track for that matter, how old this book is. Next, recent campaign was designed to convince car owners they should fill their tires with nitrogen instead of air. At a cost of about $5 per tire, nitrogen supposedly has the advantage of leaking much slower rate than air, but the ideal tire pressure can be maintained more consistently, which would in turn increase your gas mileage. Before spending huge sums to advertise nitrogen, it would be wise to conduct a survey to determine what percentage of car owners would pay for nitrogen. How many randomly selected car owners should be surveyed? Assume that we want a 98% confidence interval, well, 90% confidence, and a sample percentage within 3 points of the true percentage, 3 percent points. So, again, write down your info. And, that's what we're looking for. Alpha, this has 0.02. Remember, to get your alpha value, you take your confidence interval, and you subtract 1 minus confidence interval. 98%, 2% would be alpha. Do we have any P hat or Q hat? We do not. Do we? No. Should have given you one P hat or Q hat. Let's just look at that other formula in a second. 3 percentage points. So if you look on your formula sheet up here, so here's your two ways we determine sample size. If we don't know our P hat, then we use the 0.25 here. If we do, we use the P hat and Q hat times each other right here. So if we had a P hat and a Q hat, we'd multiply together right now. We don't. So let's get to work. So I need to get my 0 alpha over 2, don't I? Alpha is 0.02, half of that's 0.01. .01, where are you? It's on in here. It's closer to this one. Oh, 0.01. Here's, okay. We have 0.0102 and 0.0099. This one's closer to 0.01, so I'm going to use negative, 2.33. Again, for the calculators, you're just going to do an inverse norm. Just do this, I'm going to change it. So our alpha is 0.02, cut that in half, 0.01. And it gives us 2.33. Casio, same thing. Excuse me. Now, our formula, if you remember, square your z-score, multiply by 0.25, divide that by the square of the error. What's the multiply? Divide by the square of the error. Type that in the calculator, excuse me, sorry about that. So we are going to type this in the calculator. Again, you can use any calculator you want, just type it in. If you don't have math type, use parentheses. If you do have math type, hit the fraction button. And we just hit the equals, and we get, oh, we need a decimal. There we go. Oh, we need a weird decimal. 1,508. Where did the TI give us on this one? I didn't do it. So make sure you always round up. I don't know if I rounded up a lot or not, so I'll have to redo it. 1,508.0 blah still has to go up to 1,509. Let me double check and make sure I rounded up on this one. I do not remember. Oh, give me an exact answer if I don't know when. If it gives you an exact answer, you can leave it as that number. However, if it has any sort of decimal, even if it's .001 or something, you still have to round up. So this can give us 150802, I think. Doesn't matter. It was bigger than, it wasn't a nice integer, so if it has a decimal, you've got to round up. So that's for that one. Lastly, we need to find P hat and E given our confidence interval. So I don't know this one off the top of my head, but I can easily figure it out. So here's my confidence interval formula. If I add these two together, the E's cancel and I'll have two P hats. So in order to get P hat, I'm going to do my upper plus my lower. Now the E's are gone, I have two P hats, so I need to divide it by 2. Wherever that is, would be my P hat. For my error, I'm going to subtract them. If I do upper minus lower, it's going to give me minus negative plus E, and the P hat will cancel. Okay, now we just type it in. And actually, we use P hat. Well, just over 2, not even about it. So that gives us 0.594 for P hat. And if you're wondering, yes, I just made these numbers up. Now I'm just going to hit second enter so I can get back here. Do subtraction. 0.171. All right. So there we go. That's how you find the P hat and the error given a confidence interval.